All right, we're going to look at domain restrictions. And so functions pull values from a domain. But in mathematics, there are some rules that limit what values we can have in certain parts of an equation. And these would limit the available values to a function. And the two rules that limit domains the most and that we're familiar with is if I have a function where the rule is 1 divided by something, or anything divided by something, well, that denominator can't be 0 because division by 0 is undefined in mathematics. It doesn't have a meaning. We will find that we will, through the techniques of calculus, find what it means to approach dividing by 0, to have some type of limit that comes out of this, some type of overall behavior of a function, but there is no answer when I divide by 0. And the other thing that we don't do is if I have some function in a square root, it has what's within the square root, or any even power root, has to be greater than or equal to 0. Otherwise, I would not get a real number returned. And so what we do is we limit the domains of functions so that we can get mathematical expressions in the functional rules that guarantee every element in X has, every element from the domain has an element in the range. So if I were to go to divide by 0, I couldn't make that guarantee. So I have to exclude 0 from the domain. Let's look at a few examples. So I'll switch colors here to do examples. And the first example I'll do is I have some function, I'll call it I of t. I'll shake it up here. We'll use different variables, right? So my independent variable is t, and my dependent variable is I. And the function I'm going to look at is 1 over t squared minus t. So this denominator, t squared minus t, cannot be 0. So I'll factor out a t. And I'll treat my inequality. I have t can equal 0, and t minus 1 can equal 0, or t can't equal positive 1. So we can say that the domain for I goes from negative infinity to, but not including 0, from 0 but not including it, to 1, not including it, and then from 1 to infinity. And we create these holes at 0 and 1 in the domain, because if we had 0 or 1 within our domain, this function would be undefined for that element in the domain. And so this is a domain restriction. Our domain is restricted. It cannot have these values, 0 and 1, because there is no rule that will let it map from the domain to the range. All right, let's pull another example here. And I think I'll go to a yellow, blue. And we're going to look at, let's see here. We're going to look at 1 over, I don't want something that doesn't have a 1 over. Let's look at 3x. Oh, we'll make this g of x equals 3x over the square root of 1 minus x. So notice we have two things going on here. We have a square root function, and everything in the square root function initially, so has to be 1 minus x has to be greater than or equal to 0. But because it's also in a denominator, it can't be equal to 0. So it just has to be greater than 0. So the fact that we have the two things that limit our domains together, I lose the equality that I'd normally see from the square root. And I have 1 minus x has to be greater than 0. So I'll solve this for x. I'll add x to both sides. And what we get, once I rewrite this correctly, is x is less than 1, or the domain starts at negative infinity and works its way towards 1. And all values less than 1 will make this function usable. It allows the function to map from the domain to the range. But if the value was 1, I would get 0, and I couldn't do a mapping because I wouldn't have a mathematical operation that's defined, because I'd be defining by 0. And if it was greater than 1, like 5, I would get a negative number, and I would be dividing by an imaginary, and this would have to exist in an imaginary context. And right now we're looking at real number functions. And so these are the domain restrictions that a function can have based off of values that do not allow a mapping from the domain to the range. So we restrict those values from existing in the domain.